Hello everyone, welcome to my YouTube channel. I am Precious, and in this lesson, we want to look at the concept of logarithms with tables. We have also considered logarithms without tables, where we, looked at logarithmic equations, the laws or rules of logarithms, and all of that. Okay, so now, how do we find the logarithm of a number? Using what we call four-figure tables. Okay, so that's what we want to see in this video. Okay, so please take note that what we want to study here are common logarithms. And what do we call common logarithms? These are logarithms of numbers to base 10. Okay, so for any one that we are asking, for instance, here, this example says we should find the logarithms of the following. So please take note that these are logarithms to base 10. Okay, so we call them common logarithms. Now, by definition, what is logarithm? Now, the log of a number, for instance, if I have a number, say x to base 10, for instance, by definition, is simply the number that you will raise 10 to the power of, and it will give you this x. So, in other words, if I raise 10 to the power of n, and I get my x, it then means that the logarithm of x to base n, to base 10 is equal to n. Okay, so that's exactly what logarithm is all about. For instance, if you take 10 to the power of 1, of course, this is equal to 10. So what it means is that the log of 10 to base 10 is 1. And of course, if you check the video on the rules of logarithm, you see that the log of a number to the same base is actually equal to 1. So what about the 10 raised to the power of 2? You see that this is 100. So what that means is that the log of 100 in base 10 is equal to 2, and so on. If you look at 10 raised to the power of 0.3010, if you check this, you'll see that it is approximately equal to 2. And by the time you make use of your calculator to press the log of 2, of course, the calculator is naturally programmed in base 10. So you are going to actually get that 0.3010 approximately as the value of log 2 in base 10. So that is to say that the power I will raise 10 to get a particular number is the logarithm of that number. So if someone tells you that, for example, let me just say that x is equal to 10 raised to the power of maybe 0.5, it means that the log of x in base 10 is actually equal to 0.5. Meanwhile, for us to be able to solve problems like the example we have here, we will need the four-figure table, and the four-figure table is of course is a booklet which you can get. I suppose you should have it for this lesson, but for the purpose of our lesson, I am going to be showing us the four-figure table on my screen here, and you can see the logarithm table. You can see the way it is, and so you have numbers on the column here, and then you also have now this is 10 here, and this 10 means we are looking for the log of 10. And so there are ways to find it. You look for the log of 10. It could be under 0, it could be under 1, it could be under 2, and you also have differences. Okay, so however, before you start looking for your logarithm, there is what we call the characteristics of the log of a number and the mantissa. So for instance, now I have, let's come here, I have 75.12. Now the whole number part in this 75 is in this number is 75. So there are two digits in the whole number. So you need to get the characteristics for your log, and you need to get the mantissa part. So the mantissa is the part after, because your logarithm will usually give you a decimal number. The characteristics is the whole number part, while the mantissa is the decimal part. That's the part after a decimal point. So how do you get your characteristics? Very simple. All you need to do is check the digits you have before the decimal point, count the number of digits and remove one from it. So for example, A here, my characteristics is going to be 1 because I have two digits, and so I'm going to subtract 1 from 2 and I will get 1. Then I put my decimal point. Now to get your mantissa, that is what we do using the logarithm tables that I just showed you. So we are going to now go back to our log table. I want us to now find this. And when you go to your log tables, you take the first two digits. So I will do 75 under 1 difference 2, since I have 4 digits. And if you check, all the examples we have here are 4 digits. But if it is 3 digits, like I gave 101, you would first of all get your characteristics. For 101, our characteristics will be 2 because it is a whole number, all of them, and there are 3 digits. So you remove 1, and that will give you 2 points. And so to get your mantissa, you will look for 10 under 1, since you just have 3 digits. Okay, so but if it is 4, you will look for 10. Let's say there is another 5 here. So you look for 10 under 1 difference 5. And the difference, how do you do it? Look at this. You are going to add the difference. Whatever you get as your difference, you add it to whatever you get under here. Meanwhile, let's just use an example. So what is my characteristics? I already said the characteristics is 1. So how do I get my mantissa? I will look for 75 under 1 difference 2. So let's go to our four-figure table. Now I'm going to check down. Remember, you're looking at the first column. Of course, we have not seen 75 yet. So let's keep going down until we get to 75. Okay, this is 72. All right, I have 75 here. Okay, so now this is my 75. The first column is 0. This is under 0. So then you now have difference 1. There is no difference 0. So you have difference 1, 2, 3. Okay, of course, those are the 9 digits we have. So apart from 0. All right, so what do? I'm going to look for 75 under 1, which is going to give me this. Then we have difference what? Let's go back and check. So we are told to find under 1 difference 2. Okay, so coming back here, so let's see, this is our under 1 and difference 2 is 1. Okay, so what do I will try to now add this one to this, and if I do, I will now have 8757. If you add 1 to 6, you will get 7. Okay, so and then that is going to be my mantissa. So I will just come here and write 8757, and this is my logarithm. Okay, that's the logarithm of this 75.12. The implication of this, which you can check on your own, is that if you raise 10 to the power of 1.8757, you should get a value that is approximately equal to 75.12. Okay, so I will take the example B and I will allow you to do the example C. All right, so what do you do for B? We are looking for the log of 4137. Okay, so what is our mantissa in this case? The mantissa is 3 because the whole of them are whole numbers and they are 4 digits. So you subtract 1 from 4. So we have 3 points. What then is going to be our the mantissa? The mantissa, we are going to look for 41 under 3 difference 7. So let's try to look for that. This is our 41 and this is 3. Remember, this is 0, 1, 2, 3. So under column 3, that's the meaning of that. 41 under column 3 is 6160. And then what is difference 7? And the value there is 7. So I'm going to add 7 to this, and that's going to give me 6167. So we come back here. It means that our mantissa is 6167, and that is the logarithm of that example B. So like I said, I will allow you take on this other one. So what's going to be the value of this, in sorry, the logarithm of this. Try to do that. Meanwhile, please take note that let's take it that there is a decimal point maybe somewhere here for 413.7. It is still going to give you the same mantissa. It is only the characteristics that will change. So in this case, my characteristics is going to be 2 because the whole number before the decimal point is 3 digits. So if I remove 1 from it, I will get 2. And then my mantissa will still be 41 under 3 difference 7. So which will still give me 6167. Please take note of that. Now let's look at the next. So for the next examples, look at this. It says we should express the following as powers of 10. So this is another way of asking us to find the logarithm of this. So when you find the logarithm, you just put it in power 10, just like I did here. So I actually expressed 75.12 in powers of 10 here. So that's actually what that question is asking us to do. And you must understand that to be able, for me, it's like an application of logarithm. First of all, we want to get the characteristics of this. Now, remember our 7.241 is going to be equal to 10 raised to the power of, what's the characteristics? This is 1 digit before the decimal point. So when you do 1 minus 1, you will have 0. So it means that the power is going to be 0 point. So we need to get the mantissa now. And now to get our mantissa, we will need to look for 72. Remember I said it has to be 2 digits. So we're looking for 72 under 4 difference 1. So remember that while we go to our log table. So we're looking for 72. 72 is not here. Let's just go up a little bit. Okay, here is our 72 under 4 difference, under 4 difference 1, and difference 1 is 1. So just add 1 to this, you get 8598. Okay, and that's what we will have here, 85 and 98, and that's just the solution they are looking for. So because once you raise 10 to the power of the logarithm of a number, you will get back that number, okay, from the definition I gave. Okay, and then for example B also, I will do B and then you will do the last one. So you have 8.284, and we are asked to express it in powers of 10. So we are going to have base 10 here, and then the power is also going to be 0 point because the digit before the decimal point is 1, and so we have the characteristics as 0. Okay, so let's go. So what are we going to look for to get our mantissa? We are looking for 82 under 8 difference 4. Okay, so let's now go to our table. All right, 82, this is our 82 under 8, this is 8 here, then difference 4, this is our difference 4. Add it to this, you will have 9182. Okay, come back, and so our answer is 10 raised to power of 0.9182, and that is the solution to this problem. All right, like I said, please take time to look for that of example 2C and drop your solution as a comment in the comment section. And then we go over to example 3. Now, when you have gotten the logarithm of a number, what if you are asked to get back the number that gave you that logarithm? Look at this example. It says we should find the numbers whose logarithms are represented below. How do we get back the number that gave us a particular logarithm? To do that, we have to do use what we call the anti-log tables. So they are asking us to find the anti-log of these numbers here. Find the anti-log of these numbers. And to find the anti-log, what do? You make use of the anti-logarithm table. And this is the anti-logarithm tables, how they look. Okay. Okay, so we have all of this tables, and if you check now, you can see that the anti-log table starts with 0 point, and I'm going to show you how that comes to play. Look at this. Now, to find your anti-logarithms, I'm going to be For example A, I have the antilog of the antilog of 2.1814 is going to be equal to, so here the whole number before the decimal point, which is the characteristics. You remember, this is actually the logarithm of a number, so this whole number stands for the characteristics, while the decimal part stands for the mantissa. So the whole number here is going to be used to get the position of the decimal point in the final solution you will get. So just leave it alone there. We are only going to make use of the decimal part to find the number first of all. That's the antilog of this number. Okay, and so what are we going to be doing? We are going to be looking for 0.18 under 1 difference 4. And that's why when you go to the anti-log tables, you'll be seeing decimal points, in front of the digits. So in front of the two digits that you have here. So now we are looking for 0.18. So you can see 0.18 here under 1. This is 1 here. Remember, the first column is 0, so the second column is our 1. Under 1 difference 4, and this is difference 4, which is 1. So you add it here, and if you add it, you're going to get 1517. Okay, so when we get that, so just come back to where we were, and so we write here 1517 as the value we got from our antilog. Now, but this is not the final answer. What then is going to be our final answer? We are going to make use of this mantissa here, sorry, the characteristics here, to be able to get the position of the decimal point in this number we got here. And what do? The characteristics is 2. Remember that before you got the characteristics, you removed 1 from the number of digits you should have before the decimal point. Remember, for example, here let me use here, in this case, when we had 75, that's 2 digits before the decimal point. You counted it, that's 2, and we removed 1 to get 1, which formed the characteristics. All right, so now for you to return that decimal point, you need to add 1 to the characteristics. So for this example, I will add 1 to 2, which will give me 3. That means my decimal point is going to be 3 places. So I'm going to count the first 3 digits, and then I'll put my decimal point. And so I'll count 1, 2, 3. And that means my decimal point should be here. So the value of that anti-log is 151.7. It means that the number whose logarithm was taken to get this 2.1814 is actually 151.7. Okay, so please, I hope that was understood. We're going to take the example B, and I will allow you take the other two in order to make sure you have understood this perfectly. So let's look at B now. So for B, we are looking for the anti-log of 4.2105. Okay, so in other words, we are going to use 21 under 0 difference 5 to get the number. Then we use 4 to know the position of the decimal point. Okay, so let's go 21 under 0 difference 4. Okay, let's see if we have 21 here. Okay, yeah, see point 21 here. So under 0, the first digit, and then difference 5. Is it 5 or 4? Okay, yeah, difference 5. Right, so let's look at that. Difference 5 is this column, which is 2. So we'll add 2 to this, and that will give us 1624. All right, so we have 1624. Let's bring that here. So we have 1624. Okay, so the question now is, where will our decimal point be? From the characteristics, we are going to have 4 plus 1, and that will give us 5. So we are going to count 1, 2, 3, 4, then 5, which is where after the fifth digit we should have our decimal point, and there is no digit here, so we'll add 0 to it. It then means that our anti-log is equal to 1624 and 0. So the meaning is that The number whose logarithm was taken to get this is 16,240. And you can decide to look for the log of this and see if you will get back this. Of course, definitely you will do. All right, so at this point, I will allow you take example C and example D and drop your solution as a comment in the comment section. All right, so that's how to look for the logarithms and the anti-log of numbers. And this is all I have for you for this video. And please kindly subscribe to our YouTube channel, like and do share our videos to your friends, your family and colleagues, people in secondary and different study levels. We will see you in our next video. Bye.